Hello everyone, and today I want to explain to you bedrock breaking that doesn't use up any pistons. So you may or may not have seen this, but this is the setup, or the piston layout that was actually used on Xfire's machine. That was used on Psycraft to break like a 3500 by 1000 area of the Y0 bedrock. But they did that without using up a single piston, and the way they did that is using these setups that actually don't delete pistons. The first credit where credit is due, so I think Myron Ariel first introduced the concept of piston bedrock breaking. Then he showed a layout that doesn't use up any pistons, but it wasn't this layout. On XYR's video, it says that To Know To Name designed this piston layout where we have the two sticky pistons facing here and like all this. So yeah, links to all our channels will be in the description. But I haven't seen an explanation video for this, and I had to go through a little bit of effort to find out how this actually works. But anyway, now first, let's count the pistons. So we have this piston here, sideways piston here, two headless sticky pistons here, downward facing piston here, and a sticky piston that pulls the stuff back here, and that one up top. So when I run this, so I'm just gonna go down here so you can see there's no bedrock hole at the moment. When I run this, there is gonna be a bedrock hole, you see? But the same amount of pistons is still here. So we have this piston, this sideways piston, this downwards piston, this sticky piston, these two sticky pistons, they were headless before, but now they have their heads, and this sticky piston here. This one's not really important to the actual setup as much as the other ones are, but yeah, anyway, now before you actually yell at me for using command block, this command block just clones in that, which is the setup that I set up over there, and it just clones it over here so I don't have to reset everything manually. But anyway, now looking from the top, you can see what happens here. We don't delete any pistons, but we actually do break the bedrock. And also, yeah, when the thing is cloned over, then it replaces the bedrock, so like you can see that I'm not like fake breaking the bedrock. But anyway, yeah, now I'm going to explain some concepts that are very important to understand for this bedrock breaking setup. The first one is Tautic priority. So for example, all of these have a delay of 2 redstone ticks or 4 game ticks. So you might think that these all would have the same chance at being first. And by the way, this pistons with the slime blocks, that's just to demonstrate that whichever one gets activated first will pull along the slime block structure with all the pistons. That's just a way to illustrate which Tautic gets run first. Right, but anyway, what the important part is that they actually have a certain priority to which one gets activated first. And also it has nothing to do with where the lever is, so like I could put the lever all the way over here. But anyway, when I flick this lever, you'll actually see that only this piston extended, and the rest of them got pulled along because this one was the first one to receive the Tautic, or to schedule a block event from the Tautic. And the reason is that this is just a 1 2-tick repeater. And if I actually remove this, so there's no piston there anymore, now we're going to get the next highest priority, and that one is going to be the 2 1-tick repeaters, because only this piston extended this time. But yeah, it really doesn't matter where the lever is as much, it just matters about the priority of these things. But anyway, now if I flick this lever, the next one is going to be that piston. If I remove that, the next one's going to be this piston. And if I remove this one, then the next one, or the last one's going to be this piston. But yeah, it's just important to know that this one will get processed first, then these two, then these two, then these two, and then these two. So yeah, that's Tautic priority. The next thing is a relatively simple concept. Actually, it's pretty simple. It's just that you can delete bedrock when you have a headless piston facing into it, just by depowering it, and it will delete whatever it's facing into. The next thing is instant retraction, and you may think that instant retraction is impossible, but actually I'm going to show you this piston is going to instantly retract this block over here. This piston is going to normally retract this block over here, and when I break this redstone block, if I pause my game immediately, then you can see that this block actually is already at its destination, but this block is still on the way to being there, so it's being moved. It's still a moving block, whereas that one instantly got placed over there. I just placed the headless sticky piston again into here, and you can see that this one instantly ended up over here. Now the reason for that is that this is a headless sticky piston here, and the reason it has to be headless is so that it doesn't delete the block, because if I make it a normal piston, then you can see it deleted the block. which obviously we don't want. The whole purpose of this is to instantly retract the block over there, so that's why we need the sticky piston. So basically what happens is, and this is important to understand about pistons, is that whenever any block, like any block starts moving, either extension or retraction, it always creates a block 36 of itself at its destination. So this iron block is going to create a block 36 of itself here where the piston head is. Right here, there's going to be a block 36 of an iron block. This piston is going to create a block 36 of itself over here, but that doesn't matter as much, because what matters is that this sticky piston, this headless sticky piston, is going to be retracting through the block 36 of the iron block. And essentially what that does is sets it to H0, which basically, yes, that's the block. So when this headless sticky piston retracts through any block 36, it's going to set the block of whichever block 36 it's meant to set. But anyway, yeah, you can use YouTube slow-mo again. I'm just going to try to get a better angle. Just like that, you can see that block appeared there instantly, where this one took some time to retract. But anyway, remember I said that the pistons, when they retract, they create a block 36 of themselves at the piston base. So you can actually use the same thing to instantly finish the retraction of a piston. So you can use YouTube slow-mo. I'm gonna also place a normal piston right next to it so you can see that the comparison between the instant retraction, which is this piston, and the normal length of the retraction, which is this piston. So if I break it, you can see, yeah, this piston instantly retracted, whereas this one used the animation time to actually take some time to retract. But the next thing is the duplicate block event scheduling. So here, you already know about tau ticks, so you should be able to figure out which one gets activated first or deactivated first. So yeah, but anyway, I'm gonna use glass to represent tau ticks and concrete to represent the block event. So the first tau tick that happens is this one. You should know that, because that's just a 1-2 tick repeater. And the next one is this one, which is two 1-tick repeaters. And the next one is this one, which is a comparator with a repeater. Alright, so what happens once we process the tau tick in the tau tick phase? First, we get a block event for retraction here. That doesn't mean anything started to retract yet, it just means we scheduled a block event for retraction. So that's that tau tick. The next one is this one, which you can see also depowers this piston, which schedules a block event for retraction over here. Now this one depowers this headless sticky piston, which schedules a block event for retraction over here. Alright, tau tick phase is over. Now the next thing that happens is the block event, or I should say the next important thing that happens. So the block event phase, here, the first one that got scheduled is going to be the first one that's going to get executed. So this orange one was the first one, and now the piston is going to start retracting. When it starts retracting, it sets this block to air so that it can start moving the piston back over here, and that actually gives an update to this piston here. Now this piston, it knows that it's not powered, and since it got a block update, then it's like, oh wait, I'm not powered, I should schedule a block event for retraction. And it's going to schedule another one because it doesn't know that it already scheduled one. So yeah, and the important thing is this one's going to be even later than this block event. But anyway, the next important thing that happens is this. So the magenta block event, and that basically makes this piston start retracting. So there's going to be a block 36 of this iron block right over here. So yeah, it's going to be important for later. Next thing is this blue concrete. This is going to depower this headless sticky piston, which is going to retract through the block 36 of this piston here, which basically makes it instantly retract. But that doesn't actually instantly retract this block here, because this only made this piston instantly retract. The block is still moving on its way here. That's where the last block event comes in. So this one, there's a block 36 of this iron block over here, if you remember. Now this piston, it just got another block event for retraction that it has to execute, and that means it's going to have to retract through the block 36 of this iron block, meaning that it's going to instantly set this block over here. So yeah, if I flick this lever and pause the game immediately, then you could see that this iron block actually immediately ended up over here, and this piston head is still retracting through it, because it just got another block event for retraction. And you can see all the other stuff is just retracting normally, but the important part is that this iron block is actually immediately over here. I can't imagine what this particular setup is useful for, but maybe like a flush with the floor instant retractor thingy. Yeah, I don't know, but like you can see that instantly retracts that iron block from over there to over here. And you can see if I just do it normally, because now there's no sticky piston there. If I just do it normally, it actually takes the normal retraction time to retract the block through the yapping over there. So what's important really about this setup is we get like two examples of the instant retraction. The first one instantly makes this sticky piston finish retracting, and it's gonna make it be over here. And the next one is gonna make this sticky piston retract again and retract through this block 36 of the iron block over here, which basically sets the block of the iron block at its destination. Right, so that's the duplicate block event scheduling. Now we can schedule two block events for the same piston, for the same spot rather, and have them both execute as planned. Now the next two things are actual bedrock breaking setups. The first one is Marineria's bedrock breaking setup, of course. And what this is demonstrating is that the block events that the piston schedules aren't actually tied to the piston that scheduled them. I'm going to explain first what goes on here. So first is the tau tick phase. So the tau ticks get executed. The first tau tick is this one, the orange one. That's this 2-tick repeater. Next one is that one. And the next one is that one because there's a redstone dust in between them. It could also be a block. Now block events. This orange tau tick schedules a block event for this one. This magenta tau tick schedules a block event for this sticky piston, and this one schedules a block event for retraction. They're all retraction block events, by the way. But it schedules a block event for retraction for this piston that's facing upwards. Now it's block event phase, so the first one that happens is this one, the orange one. What that does is it retracts this downwards facing piston through here, which also deletes this piston. It deletes the upwards facing piston, but what's important is that it retracts this piston that's facing downwards into here. So this piston is now on its way here, but we need the second headless sticky piston to instantly finish that retraction. So because there's a block 36 of this downward facing piston over here, then since this headless piston retracts through that block 36, then it's actually going to instantly set this downward facing piston over here. Now the last block event to get executed is this one, and that was a block event for retraction, but now this downward facing piston is in this position. And block events aren't actually tied to which piston scheduled them. Yeah, since the piston that scheduled this blue block event only scheduled the block event for this position. That means that we can like shove a different piston into that position, and if we do fast enough, so before this block event actually gets executed, then we can make this piston retract instead of this one. And that's actually exactly what happens. We make this piston that's facing downwards retract through the bedrock, and that will break it. So again, one more tour down the bottom. You can see there is no bedrock hole. Once I flip this lever, then some stuff happened and there is a bedrock hole. Now another important thing that I may have noticed is that the piston that was facing upwards was actually the one that got deleted. And the reason for that is that the one that was facing downwards here actually got rotated because the block event actually does store some information about the piston. It stores the rotation of the piston, for example. So it knows that this upwards facing piston was facing up, yeah, because the block event remembers that. But it doesn't actually use that rotation when it decides where the piston that's there should be retracting. So this piston is free to retract down all at once through the bottom, but what's actually important is that the piston, after it finishes executing the block event, then the block event actually makes it get rotated. Because this piston that was facing up is the one that scheduled it, and the block event remembered that the piston was facing upwards. So yeah, again, just to demonstrate no bedrock hole, click the lever, bedrock hole. The next thing, or the last concept, is the 1-8 flickering behavior. So this flickering behavior, part of it is that this piston, so if I'm not going to bother with the tau ticks, I'm just going to place the block events where they are. Alright, so this piston retracted through here, this piston's on its way here. This stick piston instantly finished the retraction, this downward facing piston is now over here. Now this downward facing piston has a block event for retraction, but if we power it before it has time to actually execute that block event, then it actually will set its state to extended without bothering about the piston head, because it has a block event for retraction, but it's powered. And what this actually does, so on the side here, see, you can see, so this is the normal thing, the repeater with another repeater. But when this gets depowered, this comparator is actually going to power up again, because you can see this comparator is actually depowered. It's just a visual glitch that it looks like it's powered. But if I just disconnect it from there, this comparator is actually depowered. But when I depower this side, then this comparator is going to turn on. But what that does is basically gives this block here a 0 tick off pulse. That's enough to give a block event for retraction for this piston that's facing upwards, but short enough so that by the time this piston facing downwards comes over here, it has a block event for retraction, but it's still powered. So essentially, piston then gets confused and it sets its state to extended. So yeah, if I flip this lever, then you can see it set its state to extended, but it didn't care about the piston head. So if you remember one of the things over here, that this piston is actually facing upwards, that's because it got rotated, and that's going to be a dilemma with our setup if we want to put it on a flying machine, because obviously we'd have to do it again if we want to rotate it. Now this basically it preserves the rotation of the piston by doing that. So if we actually, I guess, I don't know, yeah, just remove this redstone dust, then since this is a headless piston facing downwards, if you remember from the first exhibit about the headless pistons, do actually break the bedrock that they're facing into. So you can see there's bedrock right now. If I break that redstone dust and then break this piston, you can see there's no bedrock anymore. Right, so yeah, that's just part of the 1-8 flickering behavior, that if the piston has a block event for retraction here, this piston that's facing downwards, but it's still getting power, then it's actually going to set its state to extended, but it's not going to care about the direction its original piston was facing, because technically the block event failed because it's still being powered while it has a block event for retraction. So yeah, that's just a bit of cool stuff that we can actually get a downwards facing headless piston. I showed that in a previous video of how you can actually do that in modern versions. But yeah, you can see this, the problem here is that this still actually deletes a piston, and we don't want that. That's where this piston layout comes into play. Okay, so this is the piston layout that it says that to know to name designed. Okay, so I'm just gonna power these pistons here so that they don't accidentally depower when I'm placing blocks around them. Alright, so now that we know all those concepts, it's important to understand how this layout works. So the first thing that happens, and I'm not going to speak in italics yet, I'm just going to be placing the block events in order. The first thing that happens is a block event for retraction for this piston here. That's going to be important for the duplicate block event scheduling, if you remember, because this piston is only here to update this piston. Anyway, the next thing that happens is this. We have a block event for retraction right here for this sideways facing piston that's in the middle. Now the next thing that happens is a block event for retraction for this headless sticky piston. It actually doesn't matter which headless sticky piston, it could be either one. But anyway, the next thing that happens is a block event for retraction for this sticky piston over here. That basically retracts this whole structure over here, which retracts this piston. It makes it start moving into this position. So that's important that's what's gonna do. Now the next block event that gets scheduled is this one, which actually retracts through this position, which at this time, this downward facing piston is going to be moving over here, which means it has a block 36 of itself at the center point. Now this headless sticky piston is going to retract through that place, and that's going to instantly place this downward facing piston over there. Alright, but now executing the block events. So this one depowers. That's actually going to schedule another block event over here at the middle point. Now the next block event that happens is this one, and that's going to make this piston that's in the middle start retracting. Now this is the next one that's going to happen, and that's going to make this piston instantly finish retracting. Next one that happens is this, and that's going to make this whole structure move over here, and therefore it's going to make this piston that's facing downwards start moving into this position. Now this headless sticky piston is going to retract through here, and that's going to make this downward facing piston instantly appear over here. And the last one that gets happened is this one, the last one that gets executed, and that's just going to make this piston that's facing downwards retract through the bedrock. Alright, so now that you know in general how that's going to work, now I'm going to show you with all the tactics and stuff in the redstone. So I'm just going to reset this. Now, don't worry much about this part. That's just, I'm going to explain that later. But anyway, the first tactic that gets scheduled is this one. Now the next one is this repeater here. The next one, I'm going to place it right next here, but it's this repeater. The next one is this repeater. And the last one is this repeater. Right, so now scheduling the block events. So this tactic is going to schedule a block event for retraction for this piston here. This one is going to schedule a block event for retraction for this piston here. This one, I'm going to place it right next to it. It's going to schedule a block event for retraction for this sideways facing headless piston. This one's going to schedule a block event for retraction for this piston. This one's going to schedule a block event for retraction for this piston. And yeah, now we're going to execute these block events. This piston, or upon retraction, it's going to update this piston here, which is going to make it schedule another block event for retraction. Now this one gets processed, and this piston is going to start retracting. Now this one gets processed, that instantly finishes retraction of this piston. Next this one, and it starts retracting this piston here over to there. Now this one, this headless sticky piston instantly finishes the retraction of this downward facing piston over here, and that basically instantly places it there. And the final one is this one, which makes it retract through the bedrock. But now, if we actually ignore this whole thing over here, and you count the amount of pistons, and you see there's no bedrock here right now. If I flick this, there's going to be no bedrock here, or actually there's going to be a bedrock hole. But now you can see that we actually rotated this piston that was facing downward, now it's facing sideways. And that's a big issue because essentially that means we'd have to perform something like this again to rotate the piston back the way we wanted to. And that's why we use this bit of redstone over here. This basically takes advantage of the 1/8 flickering behavior, and after 4 game ticks places the redstone block over here at this spot. And that's gonna repower this position, and if I actually remove this observer here, then you can see what it actually does is it places that redstone block over here, and now we have a headless piston facing downwards. Now the next thing, what I had this observer here for was just to update the piston again, and that's just gonna, yeah, just retract this redstone block back out of the way so this piston can retract through the bedrock. But yeah, so these observers just, yeah, power this piston back on, or rather back off, so it retracts this redstone block back out of the way so that we can make this piston that's facing downwards automatically retract. But yeah, if I just flip this, you can see that the piston actually placed the redstone block here and then retracted it back. And what that did is when it placed it, it did the 1/8 flickering behavior so that this piston actually became a downward facing headless piston. And then when it retracted, it depowered the headless piston, which basically broke through the bedrock. Now I want to briefly explain why you can't do this setup in modern version. So what's the special thing here is that this piston that's facing sideways here at the center, the only thing we use this piston for is basically just to, yeah, schedule block events. So that later when we place this piston that's facing downwards over here, then we can actually execute those block events using this piston, or rather one of them. But anyway, this piston is basically just like the block event scheduler piston. In modern versions, there's no way to instantly retract this piston, which means that the only way to get rid of it so that we can actually place this piston over here is either to destroy it or, yeah, to destroy it. That's the only way, really. Here, because we use the instant retraction, this piston became a solid block, which then we could push it out of the way so that we can shove this piston into that place. In modern versions, we can't make this piston instantly finish retraction, which basically means that, yeah, there's no way to get rid of this piston facing here, and get it out of there. But yeah, so if anybody knows how to schedule a block event for retraction and this spot without using a piston so that it's something we can push out of the way, that would be great. But as far as we all know, there's no way to do it. We have to use a piston to schedule the block event for retraction. And yeah, so that's kind of, yeah, a bit of a downfall that we can't do this in versions 1.13 and above. But you can make bedrock breaking setups that use up pistons, so yeah. But anyway, yeah guys, that's gonna be it for today. I really hope you enjoyed this video. If you want to see more stuff like this, make sure to subscribe, and I'll see you in the next one. Bye.